This is a video about the separation of compounds from crude oil. As you'll know, crude oil is a mixture of hundreds of compounds, all of which, or most of which, can have great use for us. For example, fuels, obviously, but also industrial lubricants, solvents, and making of polymers, which is of course very important for plastics industry. So how do we make these? Well, they're separated in essentially a fractionating column. This is a very simplified version, and I've drawn it this way just to help you remember the key facts. You take this great big series of chambers, so it's a big tank with some separation chambers, and you put a lot of heat at the bottom. So the crude oil is put at the bottom, you heat it a lot, and the compounds will rise up through. Now, how does it work? Well, if the heat's at the bottom, the further you go up, the cooler the column is. Although you might think, of course, heat rises, these separate chambers essentially mean it's harder for the heat to get through. So it's cool at the top, hot at the bottom. Now, compounds with high boiling points, usually the bigger, more dense compounds, they will travel only a short way up the column before essentially they condense, because it's no longer hot enough to keep them as gases, so they condense at a lower chamber. Compounds with a low boiling point, that are naturally gases, for example, will travel all the way up, and they don't yet reach a point where they condense because it's still warm enough for them to remain as gases. So up here you get things like refinery gases, methane, ethane, propane. Further down you get things that are useful as fuel, like octane and kerosene. Further down, like heavy fuel oils, and further down still things like bitumen and tar. So that's the essential principles of the fractionating column. Hope that was useful. Thanks for watching.